2010 Form B question number 6. We skipped over question number 5 because we don't know how to do that one yet. So question 6 says, two particles move along the x-axis for 0 in between 0 and 6. The position of particle P at any time is given by this function. The position of particle R at any time is given by this function. And again, this is a non-calculator question, so both of these we're going to have to work with by hand. Part A says, for the interval from 0 to 6, find all times t during which the particle is moving to the right. Okay, so remember that particle direction, when you're moving a particle along a straight line, the direction that it's moving is determined by the velocity function. So if the velocity is positive, it's moving to the right. If the velocity is negative, it's moving to the left. And so this is actually the position function. It gives the position of the particle. So the velocity would be the derivative of this. So for part A, we have to find the derivative of this. And then essentially we have to figure out, I'll show you guys right over here. We have to figure out where that derivative, so the derivative of t cubed minus 6t squared plus 9t plus 3 is 3t squared minus 12t plus 9 equals 0. And so to figure out where that function has critical points, we have to set it equal to 0 and solve for that. So we get t equals 1 and t equals 3. And then I just graphed it. I did a quick sketch of what it would look like, and it's a parabola facing up. So in order to figure out where it's moving to the right again, that means that velocity is positive. So the intervals where it's positive are from 0 to 1 and from 3 to 6, since my endpoints are 0 and 6. And then it would be negative, or in other words, moving to the left in between those two. So in between 1 and 3, it would be moving to the left. So that's the answer to part A. You get 2 points for that. 1 point for successfully finding the derivative of r of t, and 1 point for getting the answer of those two intervals. Part B. For the same interval from 0 to 6, find all times t during which the two particles travel in opposite directions. So essentially here they want to know, where is p moving to the left when r... So again, where are they moving in opposite directions? So in order to do that, we would need to we already found the derivative of this and found the zeros of that. Now we need to find the derivative of p of t and find the zeros of this function. And then we'll just compare wherever one's on top of the x-axis versus wherever one's on the bottom of the x-axis. And wherever they're opposite, that would be where they're moving in opposite directions. So let's just show you all at once. First of all, the derivative of p of t is negative 2 sine of pi over 4t. That's the derivative of the outside, times the derivative of the inside is pi over 4. That's the chain rule. So when you simplify, you get negative pi over 2 times sine of pi over 4t. Now, you could do a couple things. Number one, depending on how well you understand the graph of sine, so how well you understand that from pre-calculus, you could probably go straight to the graph of sine here, and you wouldn't even need to go through all of the steps that I went through right here. Some of you guys, however, are not as comfortable with that. So if you are, again, this pi over 2 is just an amplitude change. The negative makes it flip upside down across the x-axis. And then the pi over 4 affects the period. So the period would be 2 pi divided by pi over 4, which ends up being 8. And so that's why we get one nice, I'll highlight it right here. We get one nice period of the sine function from 0 to 8. And it starts going down first again because of that negative amplitude. So if that is something that you are very comfortable with and very familiar with, then I would say jump right into that. That would save you a ton of time, and you could easily get that graph on there very easily and very quickly. However, if you are not familiar with your trig functions and not familiar with graphing your trig functions, then you might have to go through the process that I wrote out here, which is this. Actually solve for t. So divide by negative pi over 2, so sine equals 0. And then we need to figure out where sine would equal 0. So what values of pi over 4 times t would make sine equal 0. So sine will equal 0 at 0 radians, at pi radians, at 2 pi radians, so on and so forth. And I could have kept going, but obviously in this case it doesn't really matter because we'll stop. We don't need to keep going. We only need to go to 6. So I set up 3 different times. So I said when time equals 0, when time equals pi, when time equals 2 pi. So those are the 3 solutions I got from right here. Again, let me just highlight them so you know where we got those from. And then this 4 over pi just came from right here. So I just multiplied both sides by 4 over pi. So I could get rid of this 4 over pi here. So I multiplied everything by 4 over pi. So I could get t by itself. So when I did that, the first one's still 0, the second one is 4, and the last one's 8. And then again, you could plug in points in between those to figure out if it's positive or negative. You can kind of see how this ends up just being a lot more work than graphing it by general knowledge. So hopefully you're comfortable with your graphs of sine, but if you're not, then you're going to have to go through this process. So with that said, we got 0, 4, 8, we got our sign graph. So we notice that in between 0 and 4 it's negative, and in between 4 and 8 it's positive. Now I'm going to overlay, so notice that I put our little parabola from up above. I'm going to overlay that on top of this graph. So my parabola went through the points 1 and 3 from part A, and it faced up like this. So essentially what I'm trying to do is I'm trying to look for the x intervals where they're opposite signs. So obviously right here, in between 0 and 1, the quadratic function is positive, but my sine function is negative. So they're different signs right there. So that's why I circled this interval, because they're opposite signs, which means they're going in opposite directions. Then in between those 2 points, notice that they're both negative. So my quadratic function is negative and my sine function is negative. So obviously those are going in the same direction. They're both going to the left. And then over here my quadratic function becomes positive again, and my sine function is still negative up until 4. So in between 3 and 4, my particles are also going in opposite directions. And then after 4, sine becomes positive, and now they're both going to the right again. So they're going in the same direction. So these two intervals here from 0 to 1 and 3 to 4 are my two answers, because that's where the R of t function and the P of t function are different signs. And that one is worth 3 points. You get 1 point for getting the derivative of P of t. So we got that together. We get 1 point for analyzing the sign of P of t, so understanding that it was positive after 4 and negative before 4, and you could either do that by looking at the graph or making a chart or whatever. And you get 1 point for the answer, saying that the two intervals are from 0 to 1 and 3 to 4. All right, so far we have 5 points on this problem. Let's see how many more we can get from part C. Part C says, find the acceleration of particle P at time t equals 3. Is the acceleration of the particle speeding up, slowing down, or doing neither at time t equals 3? Explain your reasoning. So remember that acceleration is the derivative of velocity. So in part B, we just found the velocity function for P of t. So now we need to take the derivative of that function in order to find the acceleration function, and we'll plug in 3. So if I took the derivative of P of t again, so this is the second time I'm taking the derivative of it now, again I have to use the chain rule, so the derivative would be negative pi over 2 cosine of pi over 4t times pi over 4. Simplify a little bit and you get this, and then plug in 3. So you need to know your trig identities and making sure that you guys understand how to evaluate trig functions. So cosine of 3 pi over 4 is in the second quadrant, so it's negative radical 2 over 2. And when you multiply that, you end up getting a positive radical 2 pi squared over 16. That was the first part. So the first part was that they wanted you to figure out this value. So find the acceleration function and then evaluate it at 3. The second thing they asked you to do was to evaluate if the particle was speeding up or slowing down. And remember, that comes from looking at the signs of the first and second derivative. So if the acceleration and velocity are both the same sign, then it's speeding up. If they're both negative, it's speeding up. If they're both positive, it's speeding up. Or if they're different signs, then it would be slowing down. So we already know that the acceleration at 3 is positive. And then down here, I went back to my first derivative again and plugged in 3 again to figure out if the velocity was positive or negative. And I got that the velocity was actually negative. So because the velocity is negative and my acceleration is positive and they're different signs, that means that the particle is slowing down. And you get 2 points for that. So you get 1 point for finding the second derivative and evaluating it at the point t equals 3. And you get 1 point for the answer with the reason, saying that the particle is slowing down because they're different signs. Part D is the last part to this, but you guys do not have the knowledge yet to answer that part. We haven't talked about average values yet, so we'll put that one off for right now.